In this video, I'm going to demonstrate how to use SPSS to carry out a one-factor chi-square analysis, which is a non-parametric statistical technique. And in this particular study, in this hypothetical study, here we have a sample size of 50 already entered into my SPSS database, and we're evaluating the proportion of people here in our sample of 50 that are left-handed or right-handed. So what we can see right here is that the first 10 participants we have entered are left-handed, and the remaining are right-handed. So we can take a look at this and say, well, obviously we have more right-handed individuals than left-handed, but the question we ask with a chi-square, is this difference statistically different than what we might have expected if our expectation was the same number of both left and right-handed individuals? Before we go ahead with the analysis, I'm just going to point out here in the variable view how these data were entered. So we have participant heading, and I have that entered in as a string so that the numbers represent not a numerical value but just as an identifier for the individual. And I have the numeric for handedness, whether it's right or left-handed. And under values, I'll just click this right here. You'll see I entered 0 for right-handed and a value of 1 for left-handed. If I had another value to enter, I would just hit the plus sign and I would enter in a value with a worded descriptor here, but I don't want to do that, so I'm just going to delete that, and I don't need to save this because it's already saved. So I'm going to cancel that. When I go back to data, I can click this variable here and go to the value labels, and you can see I can switch back and forth between the numerical value and the worded description, and that aids in keeping us aware of what we've entered into the SPSS database for our variables. So now I'm going to carry out the one-factor chi-square. So I'm going to go to Analyze, and I'm going to go to the non-parametric tests, and I don't want one sample, I want legacy dialogues. So when I click on, or when I move my cursor to legacy dialogues, I'd have a number of other options here, and I want to select the chi-square. That's what I want to do here when I'm comparing these frequencies. So as you can see here, I already did this already. Normally, the handedness would be listed here on the left-hand side. So I'm just going to move that over to the right-hand side, and you'll see under expected values, all categories equal is the default, and that's what I'm evaluating. So I don't have to change this, where my expectation or the expected frequency is that the number of people that are left-handed will be equal to the number of people that are right-handed. And then over here on the left-hand side, I'm getting from the data, so I'll just leave that. And I'm not going to do these other options here. I'm not going to use right now, but you can see you can generate descriptives and quartiles. I'm just going to click those off for now because I'm not interested in that here with this analysis. So now that I have this set, I'm just going to hit OK, and you'll see here we have our first table which depicts our observed sample of right-handed, and we have 40. Our left-handed is 10, that's our observed, and our expected at 25 and 25, and this is our contingency table. The chi-square statistics are indicated here on the second table, where we have the actual chi-square value of 18.0. We have a degree of freedom of 1 since we only have the two categories here of right-handed, left-handed, and the level of statistical significance in whether we reject the null hypothesis, moving us to the alternative hypothesis, as you can see here, is less than 0.01. 1, the risk of committing that type 1 error where we reject the null hypothesis when we should not have rejected the null hypothesis. So we would interpret this as stating that there is a statistically significant difference between the number of people that are right-handed and left-handed beyond what we would expect uh, 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 from an from assuming there's an equal number. And the risk of making a mistake on that, as you can see here, of that statement, is less than 0.001 at the level of statistical significance. So this ends this video on how to conduct a one-factor chi-square analysis.